Hello, my dear student. How are you? A very warm welcome to all of my dear students to our channel Easy Chemistry. And of course, today we are here to discuss some important organic reactions. Some important organic reactions which are basically very important for NEET, for JEE, or many others entrance exam after plus 2. Not only this class will be very helpful for the students who are preparing for JAM chemistry or who are preparing for their exam in BSc chemistry also. So let's start, and before going through the class I must request all of my dear students to please subscribe my channel, and if you do have any queries or any doubts, please write down in the comment section, otherwise I won't get your problems. Okay, therefore let's start. So, first example, if the cyclohexanone is treated with such type of typical very complex uh, reagent, and then it is treated with H2O plus, then what will be the end product? This is a very important example, and very often asked. So this is a wittig reaction. This is basically comes under a name reaction. This is wittig reactions. This is wittig reaction. My dear student, I hope the board is quite visible, and if the board is not visible, you can write down in the comment section. Okay, so when cyclohexanone or any other cyclohexanone, not only cyclohexanone, but if any other carbonyl compound will be treated with the phosphorus derivative, this is a aldehyde, and it gives the charge separation structure like this. So P, this is plus minus OCH3, and this type of charge separated structure is called betaine. This betaine, this is a charge separated structure called betaine. Okay, and this is the wittig reagent. Okay, so betaine will be formed basically this is the wittig reagent. It is called wittig reagent. If wittig reagent is treated, then this is the polar, so this is O minus, this is CH3, and basically this is betaine, negative charge, like where this phosphorus, and it like this. So this is called this type of compound called oxaphosphetan. This type of oxaphosphetan, this is called oxaphosphetan, and after the rearrangement reaction it becomes like this. See, where hydrogen is there, so this is CH3 and this is triphenyl phosphine oxide, and if this compound is given H3O plus, the end product will be like this, CHO. So this is the end product. I am not going through the detail of the mechanism because you can do the reaction mechanism very easily, so this part is not very important. The main mechanistic pathway of the wittig reaction is this. This is the main mechanistic pathway of the wittig reaction, and this is the end product. So if you give this, the end product will be aldehyde. So by by means of this reagent you can also convert the ketone to this aldehyde by wittig reaction. Okay, my dear student, so please write in your copy, otherwise you all forget this. So next example with some stereochemistry application, stereochemical application. This is the stereochemical application. So now our next example will basically based on the stereochemical application or wittig reaction. So our next example, so if such type of compound is given, so this is CH3 and here also CH3, so this is a epoxide very often, so it is a oxygen or epoxide type of compound, and both the CH3 group are below the plane, both the CH3 groups are below the plane, and both the hydrogen atoms are the above the plane. So this is a cis compound because similar type of groups are attached in the same site. So this is a cis type of compounds. What is the name of this compound? This is cis. This is 2 comma 3 because this is oxygen is numbered as 1, oxygen numbered 1, this is 2 3. So there are two methyl groups at 2 and 3 positions, so this is 2 3 dimethyl. So this is 2 3 dimethyl oxygen, this is 2 3 dimethyl oxygen. So if 2 3 dimethyl oxygen is treated with triphenyl phosphine, what will be the end product? Very often you may ask this. So phase 3, phase 3, phase 3, so triphenyl phosphine attack any of these two carbon atom, and here it sits like this. So negative, this is hydrogen, this is phase 3, and this side triphenyl phosphine, this side hydrogen. But to make the butane like structure, that is the bond, to make the bond between the negative oxygen atom and the positive charge phosphorus, so these two polar tropic or the two polar head, that is O minus and P plus, should be on the similar side, otherwise bond cannot exist or bond cannot be formed. So there will be a rotation around this sigma bond, so the rotation should be 180-degree rotation. This should be 180-degree rotation, or the rotation will be like this. So this should be 180-degree rotation. So after 180 rotation, phosphorus atom comes like this side, 180 rotation, and CH3 group which below the plane comes above the plane, and the hydrogen atom which above the plane obviously comes below the plane, and here no change because rotation is occurred like this, so this side remain intact. Now the bond exists. Phase 3, phase 3. So what happened next? So in next example like this, so here this is side CH3, this side hydrogen, this side hydrogen, this side CH3, because after formation this alkene will be formed. So this is sp2 hybridized, so all these groups will be on the similar plane, 180 degree bond angle. So this is a trans compound actually. So this called trans 2 butene. This is called trans 2 butene. So the end product will be trans 2 butene. The end product will be CH3 hydrogen, here CH3. So this is trans 2 butene. Okay, so this is a very important stereochemical aspect of wittig reaction. So my dear student, our next example will be some more now. Our next example with the rearrangement reactions. We will focus on rearrangement reaction after this. So our third example. Okay. So if this is CH2, this is OH, and this is NH2. Okay, so this compound is treated with HNO2. What will happen? If this compound is treated with HNO2, what will happen? Okay, so this is basically more rearrangement reaction. And what is the name of this type of rearrangement reaction? This is called pinacolrearrangement rearrangement reaction. So this is a pinacolone type rearrangement reaction. This is pinacolone type rearrangement reaction. So this is the pinacolone type rearrangement reaction. Pinacolone type. So what happens here? If you treat, so this is pinacolone type rearrangement reaction. Previously we have seen two types of wittig reactions, two examples of wittig reaction, and this is the pinacolone type reaction. So what happened here? If you treat it CH2, this is OH. When you treat CH2 with HNO2, if this is NH2, this will form azo compound. If you treat HNO2, then the NH2 reacts with the HNO2 and OH, and this will form azo compound. This is plus. So it will form azo compound. So this is basically very unstable compound because this is a polar compound. So the N2 will be eliminated. So when N2 will be eliminated, the bond shift. So bond shift. So there is the bond shift. So as the bond shifts, the ring expansion will occur because this is a 5-member ring, 1, 2, 3, 4, 5, and after shifting the bond to this carbon atom, it will expand to a 6-member ring. It will expand to the 6-member ring, and here the OH. If you number this carbon atoms, 1, 2, 3, 4, 5, up to 6. So this is oxygen, the hydroxyl group attached to the 5th carbon atom, so it is 5, and the bond between 1 and 6 carbon atom, so this is 6. This is 6, and the first carbon atom, so this is 1, 2, 3, 4. Okay, so here look, the bond, all this is the bond, the bond between the fifth carbon atom and sixth carbon atom. So this is the bond between fifth carbon atom, sixth carbon atom, this bond. So this is this bond. Okay, and the newly established bond between first carbon atom and sixth carbon atom, because this bond, this is first carbon atom, sixth carbon atom, this bond. Okay, so it is not very difficult. So then H3O plus, H3O plus basically, H3O plus basically obtained from HNO2. So it gives, after treating with the H2O plus, it gives like this. So this is cyclohexanone. Cyclohexanone. So when HNO2 is applied to this, cyclohexanone will be formed. This is our end product. So this is our end product. So my dear student, you can write down. Please write down on your copy book by pausing the video. Otherwise, you all forget this. So this is my experience. In our next class, we will see like this. So our next example, it will also be a pinacolrearrangement type rearrangement reaction, or basically, so fourth reaction will be like this. This is the bond. So this is a diol type reaction. This is a OH, and here a OH. This is also a pinacolrearrangement type rearrangement reaction. This will going to be pinacolrearrangement type rearrangement reaction. So H plus. So what happened? What will be the product? What will be the product? Hello my dear student, what will be the product? Any idea? Okay, then let's start with the reaction mechanism. If you know the reaction mechanistic pathway, you can easily find out the product. Okay, so no need to memorize all this product, because this is organic chemistry or any other branch of chemistry, basically full of branches of the reactions. So you may not memorize all the reactions. So if you know the mechanistic pathway, well, then you can easily find out what will be the end product. So let's go through the mechanistic pathway of this reaction. So H plus like this. So this will given as H2O plus. So H2O plus will be eliminated like this, and the bond shifting occurs. So this is a 5-member ring. So after forming this will be formed as 6-member ring. And here the OH group. Here the OH group. So here H plus ion will be omitted like this. So this will be the end product. So how this ring expansion occurred? So let's start with the numbering. So this is first carbon atom 1, 2, 3, 4, 5, and left is 6. This is 7, 8, 9, 10. It is for your simplicity only. To sake of realization, you give the numbering. Otherwise, there is no need to number this, or no formula. Okay. So this is the first carbon atom. The new bond established between the first carbon and sixth carbon atom. This is bond. So this is the sixth carbon atom. This is 7th, 8, 9, 10. So a new bond between first carbon atom, sixth carbon atom. So this is first carbon atom, 2, 3, 4, 5, and the bond, this is the bond between fifth carbon atom, 6, this bond. So this is the end product. So what will be the end product? So this is our end product, like this. So this is our end product. So my dear students, this is a very important reactions. So for this class this is sufficient, and I think you will be benefited out of this class. So at last I again request my dear student to please subscribe my channel. Please subscribe my channel, you will be benefited, and these 4 examples are very important example in your exam purpose. Okay, so don't miss this class, and in our next class we will come to very important other topics. So don't miss this class. Till then, goodbye.